coming out. Copper and sulfur. Copper sulfide. The experiment. We have our water up here. And what this is going to do is boil, adding a scientific atmosphere to our experiment. Very helpful. Just, if I could have your attention over here, we have our it's essential that I reach over flames. That way I get burned. Now we have our secondary flame here, not as important as that one. This is where all the science is actually happening. We have our heat from our burner coming up and striking this metal plate here. And get ready. You see that water up here? That's going to get heated up by that flame, causing bubbles. This doesn't even bubble. That has bubbles, indicating that we have a chemical reaction when the water is heated up. So, what more can I say? Pure science right there. We have our water changing into a gas, which is purely chemical due to the bubbles. Moving on, we'll check on that later, by the way. Now, just to continue on, I guess, we'll have our copper, and we'll push it down a little bit with our friend here. Boop. And we'll just clamp it on and put it over our flame.
Tanner is literally Rachel Ray plus science.
And we're just going to let that yellow stuff, the sulfur I guess you'd call it if you want to be technical about it, heat up and react with our copper. Bang. It'll be melting too. You see how it's melting? Yeah, look at that. And if you're wondering how skunks smell, they smell exactly like that, giving me reason to believe that skunks actually have sulfur and copper in them. So, I mean, it's, you know, what more can I say? I'm a scientist. You have to theorize, you know. And the reaction is nearly complete. I mean, maybe. I don't really know. Bada bing, bada boom. And we're gonna wander over to this fume hood before we all vomit vigorously. Yep, and there we go. Now, if we can check on our water, we can see that I messed up this very important experiment. So maybe I'll turn up the heat a little bit. If we just wait, we can see little bubbles coming up, indicating that a chemical reaction is beginning to take place between the glass and the water. The water, I believe. Forming glass hydroxide and oxygen gas. Oh, hey, I didn't see you there. Well, today I would like to talk to you about our previous experiment concerning, you know, our sulfur and our copper. I feel like we could get into a little bit more detail. So I prepared you a little index card here. The color of sulfur, however you want to say it. If we take a look here, we have our copper plus our sulfur equals our copper sulfide. But it's actually copper 2 plus our sulfur equals our copper 2 sulfide, because copper could have a charge of 1, 2, maybe 3 or 4. I mean, there actually are guidelines. And then our sulfur has a negative 2 as a charge. Copper's positive, being copper. I mean, come on. And then, you know, copper plus 2, you know, sulfide, negative 2. They equal out. Now, it's been a couple minutes, and all I want to do is take our our little chemical there and reheat it a little bit just to see if we can start a new reaction, maybe. You know, I got a great idea here. We have our skunks with our sulfur and copper in them. And, you know, if we're running low on metals, it's a fact. You know, we have copper wire and buildings with copper in them. We're going to run out of copper, but we're not going to run out of skunks. Now, what I'm thinking, I'm going to put that back. It just smells awful. I don't even care about the science anymore. It just smells awful. If we kill skunks, maybe we can, you know, grind them up into a nice paste of copper and sulfur. And we don't really need the sulfur. I mean, maybe to make eggs, if we wanted eggs. But we could have pretty much an endless supply of copper. And, you know, I care about the environment. I want to, you know, we could stop the mining. And, you know, we don't need skunks. Who needs them? You want them? I don't want them. He doesn't want them. Look at him. He doesn't want them. And I don't even know who he is.
No skunks for me.
He's not even, like, supposed to be in my video. But he doesn't want them either. So, you know, if we care about the world and environment, we got to kill these skunks, grind them down into a nice powder. You know, get the sulfur for the eggs, copper for a wire, and we can make money. We can make at least a 50% increase. And maybe, you know, a better enzyme or catalyst to get this water to boil, to, you know, incite that chemical reaction I was talking about. We can see the convection currents. We can literally see the currents of convection currenting. See? They're currenting. And if we take our lighter here and ignite, we can see some hydrogen gas above the water being released. See? See all the fireworks going on? I'm actually amazing myself right here. See those fireworks all along from the hydrogen gas. And that just proves my point that water is essential to things. Through the course of this experiment, I've discovered a new effect. I call it the Simon effect. You see, we have our little igniter here, and we have water vapor coming out. Not a lot, but enough. And we have a fire underneath. And what this causes, what I like to call an intergalactic space-time rip in the continuum of space-time. Now, if we ignite this here, see the residual effect? What I believe to be causing this would be, you see the fire, when it hits the the water, it has a chemical reaction, causing electrolytes to be expanded, and that they rip apart, causing a tear in space-time, due to the built-up energy. And when we spark this, the extra energy just gets absorbed into that, and then it gets shot back out due to the excess energy and sparks around. So we could use this for time travel even. It's a great discovery I found here. Millionaire I'm gonna be, billion trillionaire, million trillion billion trillion.